Greetings, everyone. How you doing? Going into chapter 6 here. This is a truncated version or the annotations that I've provided in the slides, and I'm doing a voiceover for this presentation on those slides. Let's get to it because I have 15 minutes. All right. So when you look at this, we talk about the elbow joint doing flexion and extension, and you also have the radioulnar joint, which is pronation and supinate. So I put some videos in here for you to follow along with. You can have us playing while you're reading to get an idea of what is flexion, what is extension, although I think most of you have that already. I'm going to just buzz through this. When you look at radioulnar articulation, you're talking about pronation, supination. So it's actually the head of the radius rotates about or over the head of the ulna. And so when you look at this, it's this position, a palm up to a palm down position. And for me, what worked was I'd use the term it would radiate over, the radius would radiate over the ulna. It's completely illogical and you won't find that term anywhere, any book, any place, but for whatever reason, just stuck in my head, and perhaps it'll do the same for you now that you're in this class. So we buzz through this and you look at this, the big ones that I want you to pay attention to are in here, you'll have medial epicondyle, lateral epicondyle, a little bit of the radial tuberosity, but understand how to orient where the radius is and where the ulna is. Those would be the big, and also the humerus. Those are the biggies. Other stuff like the coronoid fossa, yes, and then also the olecranon process and the olecranon fossa on the backside of the elbow, yes, those would be big for you guys to know. All right, so I'm going to keep cruising through this stuff. You can look at this at your leisure once it's loaded up. Oftentimes, you'll have people who will compare upper extremity and lower extremity joints, realize the elbow joint does not have a bone embedded in a tendon like the patella, so it doesn't have a sesamoid type of bone in there to increase leverage and strength. They're actually very different joints. Although you do have a humerus, which can be analogous to a femur, and a radius and an ulna, which can be very analogous to a tibia and a fibula, but the joint itself, different. And especially for the fact that you don't have in your tibia and your fibula the ability to articulate one bone over the other. Just not capable of doing that. I'll let you read through this here, but just understand with the olecranon fossa and the olecranon process, that's kind of a tongue and groove setup where as you fully extend the elbow joint, that tongue fits in that groove, and you have a thing called terminal extension, and you also have terminal flexion as well, where you can't contract or flex the elbow joint any further because mechanically you have this tongue and groove system where the trochlear fitting fits right into that notch, and you literally mechanically can't contract any further. And conversely, you can't extend any further once the olecranon process hits the back end of the olecranon fossa in the back of the humerus. I put this in here. You can kind of see it a little bit when you look at the 90 degrees of elbow flexion. You can kind of see that bony process, how it fit tongue and groove up in here on the front side or the anterior side of the humerus. Conversely, you can see here you have the ulna, and then up here you have the olecranon fossa, that kind of divot there in the olecranon process, and that's that kind of tongue and groove. And you get a good picture of that in the next slide. But realize this guy is full extension. This is 90 degrees of elbow flexion. If you were to go to full elbow flexion with the radius and the ulna up at this angle, this little tongue right here would fit right in that groove and inhibit or keep you from being able to move any further. Oftentimes you'll have clients come in, and I've had this many times, and as practitioners you'll have the same. I have a tennis elbow, I have a golfer's elbow, my elbow's killing me, it's on the outside or it's on the inside. Colloquially, those are referred to as tennis elbow and golf elbow. I make it a point to point out the difference of radial collateral ligament, ulnar collateral ligament, and I do that through this video here. In this video, when you look at ulnar collateral ligament, here's me in my garage with Batman in the background, and I'm swinging a stick as if it's a tennis racket. Boom. And you can just imagine, if I get this junk off my screen, as I'm swinging through, which is a pretty common, I'm actually a little bit low here. Most tennis you'll see a little bit higher than this, but this is the medial edge of the elbow, right? So as I'm swinging my racket, pulling through, I'm actually putting a ton of force on the medial side of the elbow. So you'll have the ulnar collateral ligament will become inflamed as a result. Or I would present with a case of medial epicondylitis. Let me swing a couple times here. I then switch this to a golf swing on the next one. And here we go, boom. So in the golf swing, the lead part of the swing is here. It's my left elbow or the lateral aspect of my elbow. And on the lateral aspect of the elbow, you have the radiocollateral ligament. So when somebody comes in, and perhaps they were doing a bunch of swings over at Top Golf, they finally get to go back and swing a dang stick. They end up swinging a couple hundred times and they blow out their elbow. Well, they're not really blowing out their elbow. They've probably just inflamed right in here. Got it? The radiocollateral ligament. And they've just inflamed it from all the impact over and over and over again of swinging. So as you're doing this, realize you might have somebody who will come in and present with ulnar collateral or radiocollateral ligament inflammation, and that would be a medial epicondylitis or a lateral epicondylitis. And usually like the golfer's elbow and tennis elbow are kind of like interchangeable. And you also have to keep in mind that in this case, it's going to be my left elbow because I'm a right-handed swinger as I swing my golf club, or if I'm swinging my tennis racket, I'm swinging with the right hand. Because I'm right-handed, I'm going to experience a lateral epicondylitis on my left hand for golf, and my right side, I'll probably get a medial epicondylitis from swinging a tennis racket. Let's let this play out for you. Oh, look at that technique. Oh, two-plane swing. Man, look at that. I just need to get out on a course. Okay. Now, carrying angle. Carrying angle is, if you understand anatomical position, it's where the elbows and the wrists fall relative to the shoulders. And carrying angle is not straight down. You actually have this outward distance, about 15 degrees or so at max. And usually it's asymmetrical. You have one side that's going to be a little bit further out than the other. But when doing like a bicep curl, you'll see trainers will start off with carrying angle position for a bicep curl, and usually that's kind of tough on the medial aspect of the elbow, and you have to go a little bit narrower, almost shoulder width. So just realize this might be a starting off point, a good talking point for a client, but this is not where you would end up doing, say, like a bicep curl or any kind of tricep exercises. All right. This is a great shot here when they talk about the radioulnar joint of showing that olecranon process and kind of how that bone sits back there like in a hook position. And so when it actually does this and articulates back and forth, it fits right into the backside of the humerus well. And that's that where the olecranon process, that tab, fits right into the slot, which is the olecranon fossa. Often overlooked is the interosseous membrane. You can even kind of see here how at the radius and how the fibers run on an interosseous membrane on a kind of angle, how the forearm would actually articulate with the radius coming up and over, in my verbiage, radiate over the ulna. But you'll have clients who might come in where they think they have they've broken a dang forearm. Oh my God, I broke my ulna, I broke my radius. Really what they probably did was during the weekend they were out chopping wood, digging holes, using an axe to kind of grub in the ground and kind of dig out a trench. And they end up inflaming this. And I've had many clients come in, they thought they totally injured catastrophically like a bone in their forearm, and really what they just did is just inflame this thing from doing too much trench digging. So just bear in mind that when you look at this, this is often overlooked. And really what I like about this is it shows the actual fibers kind of almost insinuating that internal or supination, right? Position, supination movement. But keep in mind, it comes from pronator teres and pronator quadratus as well. I left this up here for you. So when you look at the radioulnar joint, and you look at how it articulates, you can run the videos on this one, and I'll let you do that one on your leisure. And what I did was I put this in here for you as an example. And they talk about like lefty-loosey, righty-tighty. When you look at a screwdriver and driving a screwdriver, you're going from a supinated position to a pronated position to loosen up the screw. That's lefty-loosey. And then you go from a pronated position to a supinated position to tighten, righty-tighty. And again, think of this in terms of how the radius was going up and over to loosen, and now the radius is going to come back up and over, back in the anatomical position, that supinated position, as you tighten the screw. Good? Good. Love to hear it. You do a good job with these gifts in here with elbow flexion, elbow extension, They also do a good job with pronation and supination. There she goes. I like the categorization that they do in here in terms of elbow flexors and extensors. I think this is quite good, and you'll find this in the book. They do the same thing over here with kind of outlining the muscles themselves. And please make yourself very aware of some of these muscles. You'll see some of these whited out, and you'll have to fill in the blanks on what these muscles are somewhere on an assignment. Same thing here. I like this as well, how they broke this out in terms of what muscles do what. I also like how they have these outlined and they have these bolded to point out these are the muscles that make that movement happen. Very good. Anterior side of the body, these are the muscles involved in the movement patterns. Posterior side of the body, here are the muscles that are used, triceps brachii, acronosis, and supinator. And I want to get through this to get through the median nerve and a neurological component. Comes out of the brachial plexus, down through the median nerve. You'll notice when you're talking median nerve, if the thumb and the first three fingers are involved and you have some numbness or tingling down here, that's usually a red flag. There's something going on in the median nerve or perhaps further up in the brachial plexus. Same thing when you look at the radial nerve, right? With the radial nerve, if you have some issue going down the back of the arm, down into the thumb and the first two fingers, digits 1, digits 2, you know you have something going on with the radial nerve. So realize that, like I've said it before, that's your roadmap. I'm gonna go ahead and breeze through this part here. All right, bam. This is a pretty good job. I kind of like what the book does here in terms of this muscle, biceps brachii, does this, 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 and this. So I like how they break this out. The brachialis does this, true flexion of the elbow. The brachioradialis, flexion of the elbow, pronation from supinated position to neutral, and supinated to pronated. And then also this with the triceps brachii, explaining how it affects the elbow joint. So I think they do a good job here. With the extension of the elbow, you also have this little guy down here, which is used, acronosis, pronation of the forearm, pronator teres, pronation of the forearm, pronator quadratus, and in here, supinator of the forearm. I'm going to buzz into this. So I put these videos in here, I embedded them for you. So you have brachii, brachialis, and brachioradialis. I realized brachioradialis, if we change the hand position from supinated to neutral to pronated, that will change what we're asking to come to the party, right? So if we're going biceps brachii, we're going to be in a supinated position. If we're talking more brachioradialis, we're going to be in a pronated position to do our bicep curls. Boom, boom. I'm just going to get the next one here. And this is a variation, not a variation, of a regular push-up. So it's close grip with the hands in, nice and tight, and that forces the chest to quiet a little bit. And anatomically, you're loading up the triceps and the anterior deltoids a little bit more. And so as you do this, just realize when you go to full extension, you're pushing yourself away from the floor. You have that full extension in the elbow where the olecranon fossa and the olecranon process is fitting into the olecranon fossa, tongue and groove style. I got about a minute and a half left. Right down, boom, right up, boom, full extension. That full extension up top there is what you're talking about. Got it? Oh, you fucking ass. All right, a little technical issue there. Let me full screen. All right, so we did this one. Boom, got it. Boom, got it. And you have with the radioulnar pronation, you end up with pronator teres, pronator quadratus, brachioradialis. So just realize they're named off of what they do, but also what region of the body. You get out of here. So you got radioulnar supination. And with this, the biceps brachii is a strong supinator. If you don't believe me, go ahead and put yourself in like a bicep curl position and do pronate, supinate, and you'll feel the bicep actually engage there. And I gotta hustle up. Just real quick, last slide here. When you look at the brachioradialis, right, it's named for brachial region and it attaches to the radius. And it causes this to happen, pronation, supination. Just understand that the brachioradialis, based on where it originates and where it attaches, it's used either from supinated to neutral from supinated to neutral or pronated to neutral. Got it, guys? Have a good one. Thanks.